Hello, everyone. It's June 19th. All right, Saturday. I had a good sleep last night. Mediocre training session in the morning. So now let's exercise our brain. All right, nothing of concern here. All right, let's take a look. K inverse pairs array. For an integer array, nums, an inverse pair is a pair of integers ij where 0 smaller or equal to I, smaller than j, smaller than nums.length, and nums I larger than nums j. Okay? Given two integers n and k, return the number of different arrays consist of numbers from 1 to n such that there are exactly k inverse pairs in the modular. Okay, so we have 1, 2, 3, and we want 0 pairs of inverse array. So only this consists of numbers 1 to 3 has exactly 0 inverse pairs. So inverse pairs is in this array, and we have two numbers, I and two indices, I and j, and I is in front of the j, but the values in nums I is larger than nums j. So if I have 1, then we can say 1, 3, 2. 3, 2 is the pair, and 2, 1 is the pair. Okay, we get the idea. Let's do like 1, 2, 3, 4. Right? I say if I'm 1, then that means everyone has to be increasing with 1 that's decreasing, right? So we can put the largest values, or we cannot put the largest value anywhere, right? If I put the largest value in the front, then I have 2 pairs, right? If I put the largest in the middle, then I have 1 pair. So if I want 1, then the largest has to, so there's only 1 pair, right? If we move the largest can only swap with the second largest. So like 1, 2, 3, 4, but 1, 2, 4, 3, because at 4 I cannot go to previous. If I go to previous, then I have more than 1 pair. And then we move 3, right? We move 3. So any value we move, if 1 to n is sorted, any value we move, right? We move to the left in order to create the inverse. And if we do that, any numbers that's to the right of the number we want to move, they're always bigger than this value. So no matter what we change, we will not create more inverse pairs relative to the values to the right of the current one being examined. So we only need to take care of the numbers to the left, right? Which means we have a overlapping subproblem. Say we have, if we count the total number of pairs, right? Total number of pairs of n minus 1. Of n minus 1. We know the total number that exists in n minus 1 numbers, from 1 to n minus 1. Now we add n to it, right? And then all we need to consider is how to place n. We don't have to consider how to place n minus 1. Is that correct? Because n minus 1, everything that's due n minus 1, when you put the nth value into it, it does not affect. It does not affect. I think if that's correct, then I say 1, 2, 3, I know there are 2, right? There are 2 with k equals 1. Now the question is 1, 2, 3, 4. If I do 1, 2, 3, 4, that's actually not true. Hold on. So we do all the 1, 2, 3, right? That's good. Now we have 4 involved. And then we need to put 4 somewhere in it. Now 4 can put in one position, like 1, 2, 4, 3. That's 1. So 2 plus 1. How about all the other positions? like we put 4, we put 4 in any place in it. If I put 4 in any place in it, then 4 can only place in 1. So does that mean 1, 2, 3, 4 is, that means 1, 2, right? If we do 1, 2, that's 1 pair. So 1, 2, 3 is 2 pairs. 1, 2, 3, 4 is 3 pairs. Not 3 pairs, 3 arrays. Let's give it a shot. Just kind of confirm what we are currently thinking about. So let's say 4 with 1 pair, right? That I think should give us 3, right? And then anything. I think the largest number is 1,000. If we do 1,000, that's going to give us 999. Yep. Which means let's do 2, right? So if I want 2, I want 2 arrays. No, I want 2 pairs. There's only 1 pair, so 1, 2 cannot do 2. So we only can do 1, 2, 3. 1, 2, 3, if I want 2 pairs, is only have 1 possibility to have 2 pairs. 3 going to the front, right? 3 going to the front. Then, so 3, 1, 2. 3, 1, 2 will give us 2 pairs, but that's the only possible. So that's 1. How about 1, 2, 3, 4? 1, 2, 3, 4, 4 can go to the 2. Okay, 1, 4, 3, 1, 4, 2, 3, right? And 3 can go to the front. So, no, 3 to the front already done. So it's just 4 go to the front. So that means that's 2. That's 2. 4 going to this position. What if 4 goes, hold on. What if 4 goes to, if we know everything in 1, 2, 3, right? Now I have 4. Then maybe some orientation that's wrong in 1, 2, 3 can be right with 4. I feel like maybe it's not a subproblem. If 4 goes to the front, oh, hold on, that's not 1. 1, 2, 3, if I put 3 at the front, 3, 1, 2, and, 3, 2, 1 is not right. 3, 2, 1 will have 3 pairs, right? 3, 2, 1 will have 3 pairs. We have 1, 2, 3, we can do that, and 2, 3, 4, right? We can do 2, 3, 4. 2, 3, 4 has the same, like 1, 2, 3, we have, say, 1, and 2, 3, 4, we have another 1. We can do 1, 4, 2, 3, right? 1, 4, 2, 3. So it's like 1, 4, 2, 3. Yeah, that's exactly just moving 4 to the front. Does that mean if I do 2, the answer is 2? Okay, let's say 4, I want 2 pairs. No, the answer is 5. Okay, we have issues now. 1, 2, 3, 4. The answer is 5. How about 1, 2, 3? 1, 2, 3. 1, 2, 3 should be 1. 2. 1, 2, 3 is 2. What? 3, 1, 2? What else can give us 2 pairs? 2, 3, 1. We'll have 2, 1, and 3, 1. 2, 3, 1. That is correct. We have 2, 3, 1. We have 2. How do we get there? We have 1, 2, 3. and we can move the largest value, right? And then say, how about we move the second largest value? No, it's actually not the second largest. Move the smallest value. So move the largest value, or we'll move the smallest value. But if it's one pair, we can move the largest value. It shouldn't be also 2, right? 1, 2, 3 is 2. Yeah, we move the largest value, move 3 to here. Or we move the smallest value, move 1 here. That gives us 2. And if we do a 2, that's also 2. Now we go to 1, 2, 3, 4. Right? 1, 2, 3, 4. We know 1, 2, 3 has 2. 2, 3, 4, in that sense, also has 2. Right? And then what? Like 1, 3, 4. 1, 2, 3. Yeah, we can move 2, 3, 4 without changing 1. That is correct. So like any 3 values will have 2. This gives us 4. Where does the 5th one come from? The 5th one, so what do we have? We have what, 1? No, we have 3. 1, 2, 4, right? And 2, 3, 1, 4. We have 1, 4, 2, 3, and 1, 3, 4, 2. Well, the answer is 5. That means there's one more. One more. How about us move 1, 2, 4? We move 1, 2, 4. That's going to give us 4, 1, 2. Right? 4, 1, 2. Or 2, 4, 1. And then we put 3 in it. Four, 1, 2, 3. No, that gives us 3 pairs. Hold on. What's the last one? 2 pairs. Because 2 cannot do 3 pairs. 1, 3, 2, 4 is not going to work. And the only position 4 has not been on is in the first position. 4 is in the last position, and then 4 has been the second position, and 4 is in the third position. I mean, 4 in the last position, I think we already examined all of that. 4 in the second position, we're missing one. So 4 is in the second position, right? And we need 2 pairs. And if both pairs is on the right, we already have it. So we only have 1 pair on the right. But that's impossible, because 4 is the largest. So if 4 is at this position, we're definitely going to have 2 pairs, right? So if I have 2 pairs, we can choose which one to put in the front. If we put 1 in the front, it's 2 pairs. If we put anything not other than 1 in the front, then we're going to have 3 pairs, because 1 is going to be on the right. So this is not a scenario we can do. So how about 4 is in the third position? If 4 is in the third position, then we'll have 1 pair at the end, right? So we can put any value here. we need another pair. So the other pair cannot be with 4. It can only be within themselves, or with them and the values at the end. So we can say, if we put a 3 here, then if we do 4, 3, then these are two our largest. So we can do 2, 1. That's it. 2, 1, 4, 3. That's the last one, 2 pairs. Let's examine this one a little bit closer to see what actually happened here. So what happens is we secured 4 in this position, and then 1, 3, 2. Yeah, when we specify 4, right? When we specify the position for 4, and we have the remaining values, and we already know 4 is the largest, so we can only create one pair with 4. So the other 3 needs to create one pair, right? Needs to create one pair. So basically the question is, given 1, 2, 3, how do we create one pair? Well, 1, 2, 3 can create one pair by this. Either 1, 3, 2 or 1, 2, 1, 3. So we have 1, 3, 2 and 2, 1, 3. We seem to have found it. We seem to have found. Right? So basically it's like this. We will keep the largest value in its place, in the last place, and the previous we just get the value. So let's try 5. Let's try 5 and see if we get the one we want. So we know 3 give us, let's say, n equals 3, right? N is 3, k is equal to, it's going to be a 2D array, right? So n is 3. Let's say k can be what? K can be 1. K actually can be 0. K can be 0. And then just k is 0. What does 0 mean? 0 is 0 pairs, so that's nothing. So it's 1. If k is 0, let's write it out. Let's write it out. So k can be 0, 1, 2, 3, 4. Let's just do that. And this is k, this is n. N can be 0, 1, 2, 3, 4. 5. I'm going to do 5, right? So this is going to be a DP table. So n0 we don't have to consider. N equals 1. If n equals to 1, then we have no pair, so everything is 0. N equals to 2, no. N equals to 1, k equals to 1 is still 1. Like 0 pairs, right? 1 is 0 pair. I think that is 1. So if I have 1 with 0 pairs, that is going to give us 1. Whenever it's, yes, so that's 1. And when it's 1, so when it's 0, it's going to be all 1. When it's 1, right, we already solved it. When it's 1, everything is going to be n minus 1. Right? Now when it's 2, we have 2, then that's 0. So when k and n is the same, the answer is going to be 0. That's not correct. Okay? That is not correct. Hold on. That's 0, right? So I have 2 pairs. That's 0. But 3 with 3 pairs. Don't tell me that's not 0. Oh, that is not 0. So we have to compute actually. Okay. So let's try 2 and 2, right? So n equals 2, so I have 1, 2. K equals 2 on 2 pairs. We want 2 pairs, which means if we set 2 in place, 1 needs to have 2 pairs. That's a 0. Okay. So now we can move 2. 2 can move only one position, so 2 move here, right? 2 move to 2 is the front, 2 is that position, and the remaining we have 1. We only put in here, so we want 2 pairs, so we need 0 with 1 pair. 0, everything is 0. 0 with 1 pair, so that's why this is 0. Okay? 2 with 3 pairs. Those are all 0, right? This is 0. We want 4 pairs. I cannot create 4 pairs. Yeah, so if it's larger, then it should always be like that. 65. Oh, that's 65, 67. That's what I want. I want the k to be larger than n. That should give us 0. You cannot have more pairs than. All right, that's not correct. I can have more pairs. Huh. Okay, I was wrong. How do you have... I mean, you have more numbers, you have more pairs. So like, for 1, 2, 2 numbers, we only have 2 pairs, right? So if it's larger than 2 pairs, then it's not going to work. So we know the total number of pairs. Total number of pairs is... it's factorial, right? Yeah, it's factorial, which means if we go 3, factorial is 6. So if we do 5, that should still give us something. I mean, it's probably not, but I'm just saying it's because 3, the first one we have 3, 2, that's 6. So in total it's 6 different choices, but the pairs might, okay. So we know for 2, everything's gonna be 0. Okay, now for 3. 0 pair is 1. 1 pair, if we have 3, 1, 2, 3, right? 1 pair, we can say we'll keep 3 in place, and then 1, 2. So 2 get 1 pair, 2 get 1 pair, we have 1, so that's 1. Now we want to move 3. So 3 we cannot move to the front, we can only move 1 spot, right? 3 move 1 spot, so 3 move 1 spot, and then we already have, if 3 move 1 spot, right? And then anything to the right is going to be a good one. So whatever to the right is going to be a good one, which means the remaining shall produce a 0 pair. One, 2 with 0 pair is 1. 1, 2 with 0 pair is 1. So that's 1. 3 moves the front, then we have 2. So that's not good. So 3, n is 3, k is 2, is going to be 2. All right, keep going. 3 and 3, right? So we have 1, 2, 3, want to produce 3 pairs, which means if with 3 at the end, 1, 2 need to produce 3. So 2, 3, that's a 0. 3 in here, right? 1, 2 need to produce 2. 1, 2, produce 2, that's 0. And 3 at the front, 1, 2 needs to produce 0. 1, 2, produce 0, that's 1. So that's actually 1. Right, 3 and 3 is 1. Yeah, I think we find the relation finally. 3, 3 is 1. I don't know what the 1 is, but I know it's 1. Oh, did I see a pattern? Did I see a pattern? 3 is a 1, 2, 2, 1. Huh? 4 is what? 1, 3, 4. I forgot. 1, 3, 4, 3, 1. Yeah, because it's going to be like 4 with a 2, right? 4 with 2 is going to be 4 at the end, so it's going to be, we're going to do 3 with 2 plus 3 with 1 plus 3 with 0, right? So 3 was 2, plus 3 was 1, plus 3 is 0. That's actually going to be 5. Are you sure? I'm not. Let's gonna try it again. So 1, 2, 3, 4. If we keep 4, then 1, 2, 3 needs to produce 2. 1, 2, 3 needs to produce 2. So 3, 2, right? 3, 2. If 4 is in this position, in the second to the right, then 1, 2, 3 needs to produce 1, right? 1, 2, 3 need to produce 1. So 1, 2, 3 needs to produce 1. Yes. And then 4 is at the second position, right? Then 1, 2, 3 need to produce 1, only one pair, right? Only one pair. So 1, 2, 3 produce one pair. So we have actually 3 pairs. Yeah, no, we're looking at 2. There's no 3, so it's 2 pairs. Oh, 1, 2, 3 produce 0 pair. 0 pair. So it's gonna be 5. Is that 5? If we do, let's say 4 and 2. Yes, 4 and 2 is 5. Remember, we did this already. 4 and 2 is 5. How about 4 and 3? 4 and 3. So if we do 4 and 3, we're just going to add up together. That's going to be 6. Right? 4 and 3, we're going to do, so 1, 2, 3, 4. 3 and 3. Right? The 3 and 3. And then 3 and 2. And then 3 and, there's 3 and 2. 3 and 1, 3 and 0. That's going to be 6. That's going to be 6. Is that 6? Yes. How about 4 and 4? 4 and 4 is going to be 3 and 4. That's a 0. And 3 and 4. And then what? 3 and 3. Right? And 3 and 2. And 3 and 1. Because we can only do 4 positions. So that's going to be 5. So it's like sliding window sum, right? Yeah, we do 4 and 4, it's going to be 5. Yeah, I think we find it. But the question is, how do we represent it in a nice way? So we added 4, at most 4. When we do 4, right? So if we cannot add 4, we just add 2, 3, 4, and then we slide a window, right? Sliding window. So that's just going to be 6 minus 1, right? And the next one is 5 minus 2. And then, so 5 minus 2 is going to be 3, right? That's going to be 5. And so 5 is this, right? So next one is going to be minus this. So plus this minus this, right? So we're going to say plus this one, plus this minus this, plus 0 minus 2, right? So plus 0 minus 1, plus 0 minus 0. 2 plus 0 minus 0. So is it always going to be 2? I don't think so. 6. That's all 0. So plus 0. So this one plus 0, right? So 5 plus 0. 5 is this. Plus 0 minus 2. That gives us 3, right? Now this is going to be 3 plus 0 minus 2. That's going to actually be 1. And then 1 plus 0, that's going to be 0. And then just going to be all 0. So 1, 3, 5, 6, 5, 3, 1. So yes, this is going to be all parallel, right? It's a symmetric. It's symmetric. So we add add, and then we gradually remove. Yeah, that's going to be the same. So all we need to do, set I for 5, to find it, is going to be calculate the total. How do we calculate the total? We sum it. Can we? That's O(n) squared, right? We have to calculate each one. Can we directly answer this question? I don't think so. We have to compute them. We can try, right? So there's going to be this plus this minus this plus this, right? It's going to be 9. And then this plus this, 15, until we hit 5 values, 20. So we have 20. Next one, we're going to be plus 3 minus 1. Yeah, 1, 2, 3, 4, 5. So plus 3 minus 1. So that's going to be 22. And then plus 1 minus 3. Plus 1 minus 3, that's going to be 20. So the rest is the same. So it's just going down. But this path is not, I don't think it's predictable. How far we have to go? Well, depends on the k, right? Depends on the k. If I have a k value, that's the max. Do I need to go long? No, I don't have to go longer. So if I want a k is 6, right? 5 is 6, we have to know 4 all the way to 6. So, okay. I mean, we can do O(n), OK actually, OK in space complexity, but the runtime will be OK times O(n). Unless there is a formula, right? A formula to do this. I don't think I know a formula for this. I thought I found a Pascal triangle, but that is not a Pascal triangle. It looks similar at the beginning, but at the end, it's not. Okay, so we're going to say dp is going to be 0 times k. Actually, going to be times k plus 1 because we need k, right? And then we can say dp 0, no, dp 0, dp 0 is going to 1. So we're going to start with n equals 1, all right? And then we say for I, for n in range 1 to m plus 1, right? Range m plus 1. Actually, because I want to start with 2, right? I want to start from 2. So n I want to start from 2. So it's going to be from 2, right? From 2. And then what do? We do dp. So in a k, for k in range, because 0 will all be 1, so we don't have to do that anymore. So it's just range going to be 1. K can be 1 to k plus 1, right? And then we say dp k equals, right, equals what? dpk equals what? dpk equals dpk minus 1, right? K minus 1 plus dpk, that's the previous one, plus dot minus minus what? So k minus 1 is the one right before. We already hit it, right? And then that one plus this minus, we need to minus dp k. Oh, we cannot use k. Ay, ay, ay. No. It's going to be I. It's going to be j. It's going to be j. This one is j. This one is j. This one's j. So it's going to be dpj minus k. Right? No. Minus n. Minus n. So j minus n. So for example here, 0, 1, 2, 3, 4, 5. So 5 minus n will be 0. So we're going to minus 0. But here is actually minus, it is minus 0 because I need to go 1, 2, 3, 4, 5. That's the one. So 1, 2, 3, 4, 5. Right? So we have 5 values. So it can be this j minus 1 plus dpj minus j minus k minus n. All right, and then this is gonna be, we have to say minus this if j is larger or equal to n, else gonna be 0. All right, and then if dpj is equal to 0, already zeroed out, then we break. Right, so that just means there's no point going on. Wait, are we? Yeah, there we go. Then we say break. So no point going on. So we already had 0 with no point going on. And then we go to the next n, go to the next n, until we finish all the n, and we're going to return dp k. All right? So here's the test case 3, 0 is 1, right? 3, 1 is 2. I think I run a lot of test case right here. So what can I just say? 4 is going to be 5. And not throwing a 5. 5, throwing a 3. 3 is going to be 1. All right. 4, 6 is going to be 1. Right. So double check for 6 is 1. Yep, I think this is correct. Now just check the implementation. The DP table is correct. I don't think there's any issue with the DP table. N, K. Let's go. Ha! All right. This is right. 3, 1 is 2. Yeah, 3, 1 is 2. Okay, so I have a little bit issue. A little bit trouble there. So this one passed, this one passed. No, 4. 4, 4. No, 4, 4 is not 5. 4, 4. How? 4, 4 is 5. Yeah, 4, 4 is 5. What do we get for 4, 4? Hold on. At the beginning. No, at the end. just print dp, right? We'll just print dp. That's what we get. That is not correct. It's 2. Right? I from 2, and then 2, first value j, k range is 1. That's 1. 1, 1, right? And then the next one, right? The next one is going to be j, right? Equals j minus 1, this, plus dpj should be 0, right? And then minus dpj minus n. So j is 2. 2 minus 2 is 0, right? So it shall be 0. Something is not right. If j is larger or equal to n, yeah, n is 2. Oh, it's not n, I. It's larger or equal to I. And that's also not j, so it can be I. No, that's n. That is n. No, it's j minus. No, it's j minus I, right? Yeah, it's j minus I. It's j minus I. So I is 2, so j minus I, if j larger is equal to I. This give us 1, 1. 1, 1 is correct. 1, 2, 2, 1 is correct, but this is not correct. So it's 0, 1, 2, 3, 4. All right, so we have 3, 4. 3, 4 is going to be this, right? Only 3, 4. So it's going to be j is 4, so j is 3. So 1 plus dpj, that's 0, so it's 1, minus I is 3, j is 4. So 1. It becomes 2 because I already done it. Dang it. Dang it, dang it, dang it. I cannot do because it has to query something in the front. So we need to have 2 layers. Previous value. Yeah, I think we need to have 2 layers because it's already changed. It's supposed to be 1. Okay, 2 layers then. So that is just going to be this and this again. Right? That's it. We have 2 layers. So what we want is dp 1, 0, 1, and this is the same. So we can say dpj, right? No, that's j. dpj, dpij. So we have an I. dpij equals, so ij equals dp. I can do I minus 1, right? I minus 1. So ij equals not I minus 1, it's I, dpi j minus 1 plus dp I minus 1j, I minus 1j minus dpi minus 1, j minus I, if j is larger equal to I, if not, it's this. If dpij ij is 0, then we break. We have invalid syntax. Where? What was wrong? Oh, we have 2 dp's. What's the problem this time? Index out of range. How does index out of range? Oh, of course, index out of range. Hold on. How do we handle the index? So I is going to start with 2, right? But 2 is going to be 1, right? Ooh, how does that one work? That's correct. We cannot fit everything in 2. If we do in 2, the next one, oh, moly. Previous and current. And we need 2 arrays. 2 arrays. Let's call it previous and current. Okay. Pre equals this, right? Have a pre-array, and we have the current array. So actually, pre-array, to be like this. Pre-array is this, and we set pre-array. So pre-array 0 is going to be 1, right? And then for I in this, for j in this, so we're going to say current array is going to be this one as well, times k plus 1, right? This current array. And for j in this, it's going to be current. Now current array is this, and current 0 equals 1 as well. When k is 0, right? When k is 0, there is always only k is 0. There's only one array, one valid array. All right, so simply that. So this is the same, and then the change. So it could be current. All right, current j equals current j minus 1 plus pre j minus, this is going to be pre j minus I if this, else 0. And if current j is 0, then we break, right? And coming out, pre equals current. And then we return current k. There we go. I think this most likely is right. I mean, we could have just gone the full route, right? We could have gone the full route, but oh no, I forgot to mod. Oh, we have other issues as well. 1, 0, and I forgot to mod as well. Okay, 1, 0. That's gonna be 1. Okay, yeah. So that's the trouble. Oh, the current has not been if current else hold. The last one, I is the last one, last n, blah, 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 we're done. Pre equals, so pre is always in position. So actually I can say just do pre-k, because the last pre equals current. Yeah, and of course we have the mod. I forgot a mod. 1, 2, 3, 4, 5, 6, 7, 8, 9. The last one is 7. All right. Submit. Pending. Judging. Accepted. All right, give myself a round of applause. Okay, so this is a typical DP problem. The intuition is that if we have the total number of arrays for n minus 1, ranging from 1 to ranging with k ranging from 1 to k, then to compute n, we can do this. Put n in the put n in the last position. Then we need the remaining n minus 1 numbers to produce k pairs. So right, so we have the answer fn minus 1 k. Put n in the second to the last position. We need the remaining n minus 1 numbers to produce k minus 1 pairs, because we will always have one pair between n and whatever number that is placed in the last position. So we have answer fn minus 1 k minus 1. We repeat this process until n is at the first position. Then we need to produce no, not at the first. We repeat this until n is at k to the last position. Is at kth, right? The kth to the last position. Then we need the remaining n minus 1 numbers to produce 0 pairs. Thus, we have fn minus 1, 0. So, therefore, fn k equals fn minus 1 k plus fn minus 1 k minus 1 plus plus fn minus 1 0. That's actually not 0. I shouldn't say 0. It's not 0. It's k minus n. It's at the at should be the max 0 and n minus k, right? Could be 0's position or n minus k's position. It's actually k's. Okay, which position? Nth position. Either nth position, right, or k's position. Whichever is smaller. No, it said whichever is smaller. Min, either nth position or k's, whichever is smaller. Then we're going to have n minus 1. This is going to be k minus min, right? K minus min n k. So that's going to be k minus min n k. And when k is small, then we have 0, right? And k is large, yeah, when k is large, we go n, right? We go n. We'll go n position back. Yep. This can be solved using a 2D array, using two arrays, one recording n minus 1, one recording k values for n minus 1, and the other recording k values for n computed from the previous one. I'm recording the k values from n minus 1. We can call it pre. Right. We can call it pre. And the other recording, the k values for n, we can call it current, computed from pre. Runtime is OKN, right? OKN. We can also observe that the values in pre is symmetrical. That means, that does mean we don't have to keep computing. We can just repeat the entire values. But it's the same. That means symmetrical. And also once we hit 0 value, the remaining will the rest of the elements in the array will remain 0. So I have OKN. Runtime, I expect fairly good runtime. Yeah, they're here. 460, I think, milliseconds. 67%. Okay, good. Technically, because it's it repeats itself, it is possible for us to, but that's just too complicated. I like how it is right now. So we set up the array, going through 2 rounds, right? And then this is the DP round, and we have a little bit break here, so to get it easier, especially if it's long, so the initial can go faster, but eventually we'll have to fill up the entire thing. And then we do pre. Yep. Let's take a look. We have solutions for this one. This one, maybe it's medium, not difficult. Ah, it's a hard one. I guess we're getting better. No, I think the reason is I had a good night's sleep, so my brain is fresh. I think that's the reason. We solved this hard problem. Talking about hard problem, I think I got a LeetCode. What's that? LeetCode newsletter, and then some dude did a 1,000 LeetCode problems. I think in total there are about 2,000 LeetCode problems, and he did 1,000 over a year. That was quite impressive doing that many. But then I take a look, he hit 55 difficult questions, hard questions. So he put majority of the amount on the medium and the easy ones. But I'm not gonna sweat it. I'm just gonna go one problem per day. You know, we're in there for a long run. We're in there for the long run. Brute force. Yeah, you have this shenanigan happening. That is not going to work. Recursion with memorization. N squared times k. Is it n squared times k? I don't think I hit n squared. dp n squared. dp with cumulative sum. There we go. That's the one. That's the one. I think this is our solution. 0 is 1. We set it to 1. Plus m. Plus larger than 0, or this. That's that. And then plus this. Another optimize. We don't need 2 arrays. Anyway, so okay. Once again, memorization. Oh, you can do 1D. How'd you do 1D? I was trying to do 1D, but I can't. Oh. Oh, that's mine. This is mine. This is mine. I have a temp. And we do all the shenanigans here, and then we do dp equals temp. That's my okay, that's still considered ON. Yes, that's okay. Yeah, that's the okay space complexity because it's O2K, right? So it's basically okay. So yes, I think we immediately hit solution number 7. Oh, wow. I mean, the good thing of coming up with the right solution the first time is I don't have to read through all 7 solutions. We already hit the best one. So space complexity is okay. Yeah, I feel it. Just took some time. Right? All right, discussion. Short. Time and space complexity. Maybe you can post yours. Yeah, I mean I can post because I already wrote it. Yeah, let's post it. I feel good. All right, I feel good, so I want to post it. I'm gonna create a new. The way I do it is always Python 3 in here, and then ONK, OKN. I like to say OKN with OK space complexity. So it's time with this space. With two arrays. Yeah, I say with two arrays. So like I'll always first give us the code. Right, I'm gonna do the code first. And then specify as Python. Oh no, forgot this part. Again. Actually, I can post the entire thing. I can post the entire thing. Right, and then oh, hold on, we can do right, and then at the end we do. So it turns into this. Yep, just post it with sufficient amount of comments. And in the second to last position, we need the remaining to produce. So we'll always have one pair between whatever number is placed in the last position until n is at min and k to the last position. Then we need the remaining n minus 1 to produce 0 pairs. Right. Two arrays, one recording the k values for n minus 1, and the other recording the k values for n computed from pre. Yep. All right. That's it. That's it for today. We're very lucky. Immediately the first. I think it took me how long? I think about half an hour. Half an hour to come up with everything. And to code it up, we hit some hiccups. I was trying to do everything inside one array instead of using a second array, and it didn't work. And we fixed that a little bit. But overall, pretty good. Overall, pretty good. I mean, definitely, there's still room for improvement, right? There's still room. Like I should see this is deep. I think I know this is DP, but I didn't realize that it has to go. The K has to go from 1, 2, 3 all the way to K for the DP to work. Anyway, we're getting better. We're getting better. All right, that's it. That's it for today. See you guys tomorrow. Adios.